is Sirawsky, and this is my final independent project for AP Statistics. I'm submitting this March of 2017. So for my project, I chose to do an experiment based on slime. Slime is a gelatinous mass that is technically a solid, but the bonds aren't really strong enough to hold it together. So you get this substance that is like squishy and almost a liquid and flowy and runny. Yet at the same time, if you squeeze it quickly, it kind of thickens and becomes almost like a solid then. It's like a runny jello type of thing. But in particular, my experiment was on the concentration of borax in the activation solution and if it affects the type of slime that you will make from that solution. I have been unsuccessful in my past attempts to create a good quality slime for the qualities that I desire in slime. Since I have failed in the past, it made me think that perhaps it was my borax solution that was causing my failure. Because of that, I figured that there was probably a difference in your slime based on your concentration of your borax in your borax activation solution. Hence, I decided to do my stat project on this very manner so that I can create slime based off of my desire in the future. Now with my slime, I desire it to be very runny compared to more of a putty-like substance. So I conducted my experiment around that factor, making it my second most important factor in my scoring process. For my experiment, I created 6 different borax activation solutions. The first one started with 1/4 of a teaspoon of borax in 1 cup of hot water. I continued that up a 1/4 of a teaspoon interval until I reached 1.5 teaspoons of borax in 1 cup of water. I then created 6 slimes based off of those solutions and evaluated and scored each slime on the qualities that I desire in slime. If it possessed the quality I desired, then I received the points that could be awarded to that quality. I then went on to do my second set. For my second set, I used half as much water as glue in my glue water solution. My first set, I used equal amounts. I was not sure whether that would affect the results or not, so I created a block design around that factor. So my second set, I went on and used the same exact borax activation solutions as I did in the first set in order to remain consistent and try to avoid confounding. The results did not differ very much. I scored my slimes based on a predetermined rubric. My rubric was as follows. I awarded each slime that formed, which ended up being all of them, 4 points, since that was the most important aspect in my list. The second most important aspect was the viscosity. Viscosity is the tendency to run. If a fluid has a high viscosity, it doesn't move as fast. It is less running. Hence, I wanted my viscosity to be low. In order to test this, I let the slime drip from my hand down to the table from exactly a foot above the table. I recorded the amount of time that it took. If it dropped to the table in 15 seconds or less, I awarded it 3 points. My next important aspect for my slime was the shear thickening. Shear thickening is when it hardens with pressure, as I was describing earlier. In order to measure this, I would let the slime settle in my hand for a couple seconds, and then I would squeeze it quickly and hard. If it didn't gush out of my hand and start falling towards the table, if it stayed and hardened in my hand for a second or more, then I considered it to earn the points for shear thickening. Shear thickening was worth 2 points. My last aspect, worth 1 point, was stickiness. I did not want my slime to be very sticky. I judged this by letting the slime sit in my hand for 2 seconds. I then quickly pulled it away from my hand. If it broke apart, then I did not award the points. However, if it came off and all in one piece, then I would award it the 1 point for not being sticky. I then totaled up each set. Later, once I finished both sets, I added the data together to see the results. The results for my first set, which included equal amounts of water and glue in the glue solution, were as follows. For A, the solution A with 1/4 of a teaspoon of borax, it received 4 points for formation, 3 points for viscosity, 0 points for shear thickening, and 0 points for stickiness. It totaled at 7 points. For B, with 1/2 of a teaspoon of borax in the solution, it was awarded 4 points for formation and 3 points for viscosity. It did not receive points for shear thickening nor stickiness. It totaled at 7 points. For C, which included 3/4 of a teaspoon of borax in the solution, it was awarded 4 points for formation, 3 points for viscosity, 2 points for shear thickening, and 1 point for stickiness. The total was 10 points, which was the max amount of points. For D, which included 1 teaspoon of borax in the solution, it was awarded 4 points for formation, 0 points for viscosity, 2 points for shear thickening, 1 point for stickiness. It totaled at 7 points. For solution E, which included 1 1/4 teaspoons of borax in solution, it was awarded 4 points for formation, 0 points for viscosity, 2 points for shear thickening, and 1 point for stickiness. It too ended with 7 points. For my final solution F, which was 1 1/2 teaspoons of borax in 1 cup of water, it was awarded 4 points for formation, 0 points for viscosity, 2 points for shear thickening, 1 point for stickiness, and also totaled at 7 points. For my second set of data, my raw data was as follows. For solution A, with 1/4 of a teaspoon of borax in solution, it was awarded 4 points for formation, 3 points for viscosity, 0 points for shear thickening, and 0 points for stickiness. It totaled at 7 points. For solution B, with 1/2 of a teaspoon of borax in 1 cup of water, it was awarded 4 points for formation, 3 points for viscosity, 2 points for shear thickening, and 0 points for stickiness. It totaled at 9 points. For solution C, which contained 3/4 of a teaspoon of borax in 1 cup of water, it was awarded 4 points for formation, 3 points for viscosity, 2 points for shear thickening, and 1 point for stickiness. It received 10 points, which was, again, the most that it could receive. For solution D, which was 1 teaspoon of borax in solution, it was awarded 4 points for formation, 0 points for viscosity, 2 points for shear thickening, and 1 point for stickiness. It totaled at 7 points. For solution E, which was 1 1/4 teaspoons of borax in solution, it was awarded 4 points for formation, 0 points for viscosity, 2 points for shear thickening, 1 point for stickiness, and it totaled at 7 points. For solution F, my final solution, with 1 1/2 teaspoons of borax in solution, it was awarded 4 points for formation, 0 points for viscosity, 2 points for shear thickening, 1 point for stickiness, and 7 points total. Once I added my totals together, I received their final score. A scored 14 points. B scored 16 points. C scored 20 points. D scored 14 points. E scored 14 points. And F scored 14 points. There were 20 points possible for each score. My solutions became more viscous as more borax was added to them. In addition to viscosity increasing, their shear thickening power increased as well. They also became less sticky, but I think that has to directly do with the shear thickening agent. If it's more likely to become more like a solid when quickly moved, then it makes sense for it to be less likely to break apart when it is quickly moved away from the skin. In summation, it was evident to me throughout the experiment that the concentration of borax in solution does have an impact on the attributes of the slime itself once it is formed. With less borax in solution, you trap more water in the slime, making it runnier, yet at the same time stickier. If you go for a more puttied slime, it will be less likely to stick to you, but it will not be as runny. In order to achieve that effect, you would want to increase the amount of borax in your borax concentration activation solution.